So Facebook Profit is an example of a time series model where this model can be directly used on time series data without any of the intermediate feature generation steps. So this model was created by Facebook as per the company claims for forecasting projects internal to the company. And in 2017, it open sourced it to the general public. It's a very nice tool to get started on structural time series modeling. So, what do you mean by a structural model? So, structural time series model where we have to provide salient properties of the time series that we saw earlier, like seasonality, stationary, etc., as hyperparameters when we are building the model. So, there are several benefits to using Facebook Profit. Facebook Profit can handle seasonal effects. It can allow you to add holidays directly. It can handle exogenous regressor variables, etc. Out of the box performance of the model is fairly decent for a lot of time series data, and it has a very intuitive API which is very close to scikit-learn, so there is not much of a steep learning curve, and there also exists very time series specific convenience methods like plotting, error bars, etc. present in the package. So let's see how to build Facebook Profit and use it to train on our passengers dataset. So there are mainly two packages that you need to install via pip or conda. The first is PyStan, which is the probabilistic programming language that sort of powers the backend of Profit, and the Profit library, of course. We've also went ahead and installed and imported Plotly, which adds interactivity to our plots and to our graphs. So using Profit is very similar to using any scikit-learn model. The only requirement on the input data frame is that there should be a datetime column called ds, and there should be a variable column called y. So as you can see, there is really no need to explicitly generate any shifted target column like what we did when we were implementing traditional machine learning techniques on time series data. Once you have the data frame ready, it's as easy as using the Profit class in the library to define a new model object and use fit. Since Profit is a structural time series model, you can pass various parameters like holiday effects, exogenous variables, whether seasonality should be additive or multiplicative to this Profit class while you're creating the model. This is nothing but hyperparameter tuning. To get a sense of the range of arguments and parameter values that Profit class can take, refer to the documentation. What happens during prediction? During training, Profit required two columns, ts and y. During prediction, Profit really requires only one column, ds. There are two ways to go about doing this. The first method is to use the test set that we created in the previous sections, select only the datetime column from it, and rename that column to have the name ds. However, Profit also comes bundled with a lot of nice convenience methods designed to make your life easy. For example, the first convenient method that we encounter will be the make underscore future underscore data frame method. This method allows you to extend the training set that was used to train the model by a certain time period. As you can see in the slide, the parameters of this function determine how many points, what the frequency should be, etc., while extending the training set. So the resultant data frame, future, also contains the training points as well as these extended points. So how does predict work in practice? So the predict method, as we mentioned earlier, is very similar to scikit-learn. So you pass a data frame with a single column ds to this method, and you get a variety of predictions for each datetime point as a final data frame. So here we are using a variable called forecast to kind of catch this returned data frame. You not only get point estimates like any scikit-learn technique like y-hat, but also really nice informative uncertainty estimates, trend, seasonality components, etc. So for sake of brevity, we are showing only three columns from the forecast data frame. So the trained model has a plot method, which accepts a data frame with all these prediction related estimates that we saw in the previous slide and generates a graph for us. So if you look at the slide, there are three main things that you need to pay attention to. The first is the solid blue line. The solid blue line represents y-hat for each date and time. As we mentioned earlier, y-hat is nothing but the maximum likelihood point estimate. The second is the blue bands, upper and lower. They represent the 95% confidence interval for the upper and lower estimates for y hat, and they sort of quantify the uncertainty behind the prediction. Lastly, you have the black points, which are nothing but the actual train and test data points in our data frame. In addition to the plot method, the profit model also comes with a nice convenient plot underscore components method, which allows you to visualize the different structural components of your profit model. As we mentioned earlier, this is possible because your profit model is a structured time series model. Now that we have trained our model, let's see how well it holds up. We will use the same metric that we used to evaluate the baseline and the linear regression models earlier. If you remember, it's the mean absolute percentage error, aka MAPE. As we mentioned earlier, both the future and the forecast data frames that were generated already have the train points in them. We need to calculate MAPE only on the test set. So at first, we need to identify the relevant starting and ending positions of the test set in the forecast data frame. Once we have obtained the indexes, we slice and dice and select only the y hat column and compare that to the target for each month in the test set. As you can see, there's already a 30% improvement out of the box without any kind of tuning compared to the baseline. So what's the next step? The next step is to, of course, tweak some hyperparameters. In fact, we recommend you try out multiplicative seasonality. The reason behind our recommendation is that earlier on in EDA, we saw that the passengers dataset was not really stationary on account of the amplitude increasing over time. So, congratulations on making it this far in the time series analysis module.